All right, good. You're ready to go. Everybody's happy. All these things are working. All right, good.
3, 2.
Got it. All right, so welcome to the Earth Science class. This week's lesson is about rocks, which is your favorite subject, I'm sure. I already passed out a sample of the rocks that we collected here in California, but it's a good example of some of the stuff we'll be talking about today. You'll find out at the end of this presentation or lesson, you know a lot more than about rocks that you ever need. Again, we're going to use Google Earth because it gives us a good idea of where we can find samples of the stuff we'll be studying today. And at the end, we'll do a little recap or review, and also ask you a couple of questions about the material we shared today. All right? So if you have no questions, let's get started. 1 second here. And here we go. So this is Earth Science. Here's some key terms we're going to discuss. It's something that you need to remember as we go through the lesson. Rocks, basically, the definition of rocks is any solid mass or material. Obviously, there's more to it than that, and that's what we're going to be studying today or covering today. Also, rocks can be minerals. In essence, minerals are rocks, and minerals. Rocks are minerals, but there's a different chemical composition within the rock that makes it a mineral. You understand what it is. And also, the three things you need to remember out of this one lesson is the fact that there's three types of rocks at least. One is the igneous rock, which is volcano rock. When you think igneous volcano, and you got it. Metamorphic rock, which is rock formed by high temperature and pressure. I'll show you examples of that. Sedimentary rock is in layers and sediment. So in essence, when rock has been sitting there for millions of years, that's sedimentary rock, period. That's what you need to remember. We'll visit tectonic plates because the reason why we have these three types of rock is because of tectonic plates, which we covered in the past. And also talk about something called erosion, because it's a three types of rocks. What causes these rocks to change? So erosion is part of it, and I'll show you why. The one thing you'll find out from today's lesson is rocks do move. They don't stay the same. You might look at something as it's been sitting there for thousands of years, too big to move, but they do move, and that movement is called the rock cycle, which we'll cover today. And also, our rocks are webbed. You'll see an explanation of that in a minute. All right, so let's get started. So rocks are minerals, and minerals are rocks. And there's certain geological processes that happen that make this happen. And one of them is volcanic eruptions, as you can see on the visual, earthquakes and landslides, erosion, which is basically weatherization. Rocks tear down. Some of them are nicely grounded to very small pieces, otherwise stay solid because they're so big and heavy and hard. And also, rocks build up mountains. A rock is a solid mass of minerals, matter that occurs naturally. A few rocks may be composed of only one mineral, but most of them are aggregated of several minerals. In the examples that I gave you today, I drew a representation of that. For example, there's that one right there. Could you pass it forward? So this rock looks pretty solid, right? All colors look the same, hardness looks the same, relevant. But this rock does not, because you see a layer in between it. And I showed you when you were looking at it earlier, you saw that? Something happened to this rock. So this is not a solid object. It looks solid, it's hard, and it looks you can't break it, but something happened when this was formed. And there's a composition of different minerals. And I'll show you an example of how this happened. So first of all, we need to understand the rock cycle. So rocks go through a life process, and it's called the rock cycle. In essence, the rock is sitting at the bottom of the earth, in that area called the mantle or the core, and it comes to the surface because it's so hot down there. When it's underneath the surface, it's called magma, but when that hot rock comes to the top, it's called lava. And this is what you see happening, coming out of volcanoes. Volcanoes are when these rocks reach the surface, it's a very violent eruption or process. You see them spat out all over the place, mostly to the surface of the volcano, but in most cases, when it's a big eruption, it's just miles away. These things just shoot out very large boulders. So those are used to build up mountains. Whether the earth is constant, changing, and weatherization erosion causes those rocks to go down the mountain, the process of erosion, and then most of the rocks end up in the ocean or a lake or a stream or a river. And that process is called the rock cycle. So in essence, this rock eventually comes up to the bottom, they heat it, pushes it again, it's called the metamorphic process, and then up it goes again. So this process goes on and on and on. So it doesn't happen over hundreds of years. It probably doesn't happen over thousands, but it does happen within millions of years. And the fact that we study tectonic plaques, this process is happening all the time. So this is the rock cycle. Here's the igneous rock, here's the sedimentary rock, and here's the metamorphic rock. All right? And the process is it gets heated up, push up, toss out, erosion wears her down, transports it over to the ocean, the water, it pushes down again, and then the process starts over again. All right? So the process includes igneous rocks, sedimentary rocks, and metamorphic rocks. Here's a good example of visual we've seen before. And here's an example of igneous rock because it's a volcano and it's being spit out. It looks like how white to me. Over here, sedimentary rock. Rock is sitting at the bottom of the ocean. And over here, you got more igneous rock, and metamorphic rock is being pushed down. This looks like California. You can see that crust down here. It's going at the bottom. And here's California up on this side. So, good example of the rock cycle. Here's a little more information about the rock cycle. Igneous rocks, it has to be, of course, under temperature, melting and crystallization. Sedimentary rocks is stuff that's been sitting there. This is the kind of stuff we see when we go to national parks. You see the rivers and streams that water runs through, and all that rock that's sitting is called sedimentary rock. And then amorphic rock is something that's being formed because of pressure of the continents or the tectonic plates moving. So that's an example of that. So igneous, sedimentary, and metamorphic again. Here's another example of the rock cycle. Some examples you might have visited. So you see this geological feature down in Arizona. You see this kind of rock down by the beach, the sedimentary rock, because it's been sitting there. Remember, it comes from the mountain. The water moved it down to the ocean, and it looks like this eventually. And then you have another example of sedimentary rock in the desert. We have a lot here in this area. And then you have metamorphic process, which is rock that's been bent because of the pressure. Yes, sir.
Rocks that are like created by layers, when they go into magma, like under earth, and when they come out, do they change? Do they become a new rock? Or?
Yeah. But there's so much heat underneath the earth in the mantle that yes, they actually transform this rock. So this rock looks like this today, but if you put a lot of pressure on it, it will tear down to pieces and it will come out completely different. Because in essence, it's not the color or the texture or the hardness that makes it, it's the chemical process on it. When you put a lot of pressure or heat on anything like that, it will transform into something completely different. Even so, you can even do, the best example of that is graphite. Graphite is the kind of stuff you find in pencils, the lead. So the same chemicals that make up graphite make up diamonds. So scientists say, if you put enough pressure on graphite, you can make a diamond. Anybody can make a diamond out of graphite, but there's a lot of pressure. Nobody can do that. There's no process in the earth that can cause it. But that we can make it, but the earth can actually do it. So graphite is diamonds, and diamonds are graphite. Yes. Okay. So again, the rock cycle includes igneous, sedimentary, and metamorphic rocks. These are three examples of that. Let's talk about igneous rocks. Remember, this one is a process in which they are exposed to a lot of pressure and temperature. So a good example of that is magma, the stuff that comes out of volcanoes, which is a visual that you see here. And once it comes to volcanoes, it becomes lava. That's what you need to remember. Sedimentary rocks are rocks that have been basically tossed out of the volcanoes and landed at the base of the volcanoes. There's different colors. There's no one way or those rocks look. As you can see, these rocks that you saw today were picked up from one location in California. So not all rocks are the same. It was not too far from each other. So this is the one thing sedimentary rocks will go through. It's called a process called WED. Weatherization, erosion, and deposition. Weatherization, basically whenever it is exposed to water, a lot of rain, or rivers, or oceans, or the wind, it moves rocks, or it moves boulders, and they crash into each other, and eventually they come from large boulders to very small boulders. Erosion is the movement of sediment from broken rock. So basically water moves rocks, erodes it. Ice and gravity. So you see this in California near the beach, especially up in Malibu. Those embankments, when they get exposed to too much water, they just come down. There's just too much water in the ground. And deposition. Deposition is a sediment in a new place. Basically, it moves the rock. So much so that it basically becomes a desert like this. So sedimentary rocks goes through a process of weathering, erosion, and deposition. All right, it's called wet. Here's another process of a picture of the same thing. In essence, the rock is sitting on top of the mountain. It gets exposed to the water. It brings it down to next to the ocean. This is over millions of years or thousands of years. Ends up in the ocean. Eventually, it goes down into the rock cycle process again. Weathering, erosion, and deposition. Now, metamorphic rock, the last one. These are rocks that are exposed to high temperatures and pressure. They're just like igneous and sedimentary rock, except that these are underneath the earth. We don't see them on the surface. So if people dig deep enough into the earth, you start seeing metamorphic rock. This is an example of a metamorphic rock, but don't worry about the names. Worry about just want you to focus on increasing temperature and increasing pressure. As you expose these rocks to higher temperatures and pressure, you get something different. This is how it changes. Somebody asked a question about how do they change, or how does this process go? Meaning that as you expose it to a higher range of temperature and pressure, you get something completely different. Because in essence, you're not just pressing on a rock, you basically change the chemical process of the rock. See, let's skip this part. Here's a good example. Now, there's thousands of different versions of rock. This is just a few of them. You might have seen some of these, but in essence, all these are rocks. It's just that they've been exposed to different temperature and pressure. Look how different they all look. You saw that in the examples that I gave you today because they were all selected from one location. But these are rocks that were picked up throughout the world. And this is how different they look. But the process in which the rock cycle in which they go through is all the same. As a matter of fact, a good example of that is that crystal. Who has the crystal? Nancy? And this is very dramatic. So could you believe that this rock, or it's a mineral, it's a rock that's been exposed so much pressure it became a crystal. It could be the same as this. But the difference is that this is nice and shiny, you can make some jewelry out of this, but it went through the same process. If you turn it around the other side, look, it looks just like a rock, except that on this side, something happened. So this is metamorphic rock that was sitting on top of another bottom of the earth, and it went so much pressure, it turned to a crystal. This is the kind of stuff that you want to use as jewelry. Emeralds and gems and so on. This is the kind you do. This is rock that is sitting on the surface, but it wasn't exposed to enough pressure to make it look like this. But it is a rock. Except this is called a mineral because the elements are more aligned. And also rock can be judged by the hardness, so you can actually have a scale from 1 to 10. 1 being the softest, talk, and then the hardest, the diamond. I want to give you I'll bring you a sample of the diamond, but my wife didn't want to wear it with her, so sorry. You lost it last time, I don't want to lose it. Those are expensive. So it tells you about the hardness, so you compare it to something else. Here's the talc, the fingernail, the penny, knife, steel, masonry, and so on. So you get an idea that rocks, they look different, but also another feature that makes them different is how hard they are. In this scale that was developed to determine its hardness is 1 to 10, called the Mohs hardness scale. All right, now that you know everything about rocks, let's find out. Let me ask the first one. What type of rock would you find around a volcano? Don't yell it out. Is it A, igneous rock, B, metamorphic rock, C, sedimentary rock, or none of the above? Take your answer A, B, C, or D. And when you're ready, I think everybody's ready, I'm going to scan the room. Pick it up. Pick it up. And 100%. Wow. If you pick A, yes, you're right. Igneous rock. Too easy. All right, I'm going to make it hard. What type of rock would you find around near beaches and deserts? What type of rock would you find around near beaches and deserts? A, igneous rock, B, metamorphic rock, C, sedimentary rock, or D, none of the above. 92%. Not bad. Yes, sedimentary rock. Excellent. Last but not least, what type of rock is created by high temperature and pressure? A, igneous rock. B, metamorphic rock. C, sedimentary rock. Or none of the above. What type of rock is created by high temperature and pressure? Igneous, metamorphic, sedimentary, or none of the above? Ready? Here we go, here we go, here we go. We're scanning, we're scanning. I got everybody. Another 100%. Wow. Outstanding. So let's recap. Yes, it is metamorphic rock. So let's recap. So then, earth science includes a process of geology and meteorology. Today we cover rocks, and the three things you need to remember is that we have igneous rocks, metamorphic rocks, that's really sedimentary rocks, huh? And then you have plate tectonics that we give rise to these type of rocks. That's another issue will come up later on. So with that concludes our lesson. Again, if you need a copy of the lesson plan, let me know. We'll be online, and we'll sit around if anybody has any questions. Thank you so much. Oh, I forgot to pass it out. Oh, no.
Shoot that again.
Do that again.
Well, can you tell them what that was then?
Yes, I'll share what it was.
Okay, cool.
All right, I got this. I got extra. All right. What you here. Then I'll explain what this is all about. This is an experiment. So remember I told you there was layers on the earth, the mantle, the core, the mantle, and the crust.
Do you want me to start recording again? It's compressing at the moment though. Or do you want me to record a separate video?
No.
Okay.
No. So the heaviest stuff is at the bottom, right? So that's what it represents those chakras. What are they called? These chakras called? Whatever. It's at the bottom. As the rock is heavy, it's at the bottom because it's so dense, right? And as you go up higher, its chances are that it's heavy. So you got the light stuff at the top. You saw an example of the type of rock that sits in the beach in the desert. It was kind of grainy or smaller. You grind it down, nice and soft. That's the top. So this process of erosion happens all the time, and this is what happens if you were to cut up a section of a cliff. This is what you will see: the hot rock at the bottom and the soft rock on the top. With that, help yourself. Now you can shake it. And I got some release. Anybody? Of course.
Where's my community boarding cushion chairs?
The what? The what?
Where's my community boarding cushion chairs in my room?
We're working on it. How long was that? Oh, how many minutes was that?
26.
Oh, perfect. What do you have? Oh, so then, as you were looking at these things, did anybody see any crystals, anything shiny on it? No? You gotta see, not with the magnifying glass, with the other one. Where's the eyepiece? Where's the eyepiece?
Here.
You can turn it up?